organize and visualize the data. I'm sure you're familiar with many methods of visualizing the data in statistics. For example, frequency table, tally marks, histograms, pie chart, bar chart, and so on. In this class, we're going to visualize the data using some of these popular methods. A dot plot that helps you to identify the outlier, a bar chart for categorical data, a pie chart also nicely representing the data, and also a histogram. Later on, we're going to work with scatter plots and how to find the correlation between data. Let's take a look at some notations here that we're going to use in this class. When you have a sample, the sample size is basically the number of data in your collection. We denote it by small letter n. For example, if n is equal to 4, it means that your data set consists of 4 observations or counts. For example, here you have sample of universities with 4 universities listed there. And also here you have another sample of pH measurements with 4 data in your collection. If you have 2 samples or more, you can use m and n, or if it's easier for you, you can use n1, n2, and so on to represent and denote the sample sizes. For example, here you have 2 samples. The first sample is of size 3, and the second sample is of size 4. And if you have a data set consists of n observations and some variable like x, the individual observations will be denoted by x1, x2, x3, and so on. Please note that x1 and xn, they do not represent the smallest and largest values in your collection. In many applications, x1 will be just the first observation, x2 is the second observation, and so on. The ith observation is denoted by x sub I. Types of data. In our class, we're going to deal with 2 types of data: qualitative data and quantitative data. A qualitative data is all about attributes, labels, or non-numerical entries. Please note that if you have numerical entries like social security numbers, the algebra doesn't make sense on that. So that's why we put it in categories. Quantitative data consists of numerical measurements or counts, and algebra makes sense. So when you're doing algebra on the data, the result makes sense. Hair color is an example of qualitative data. Blood type is another example of qualitative data. Housing prices, salary are examples of quantitative or numerical data. In this example, we have suggested retail prices of several hundred vehicles. You have model and suggested retail price. So the model is basically a categorical data set, but suggested retail price, as you can see, you can easily, for example, find the average. What is the average of the data here? And it makes sense. Another way to display data is using a stem and leaf display. Consider a numerical data set, x1, x2, and so on, xn. For each one, xi consists of at least 2 digits. A quick way to visualize the data is using stem and leaf display. Step 1, select 1 or more leading digits for stem values. The trailing digits become the leaves. Step 2, list possible stem values in vertical column Step 3, record the leaf for every observation. And finally, indicate the units. Let's take a look at one example together. In this example, the data set lists the number of text messages sent last week by the cell phone users on one floor of college dorm. So as you can see here, you have a bunch of data. You have 78, you have 123, you have 122, and so on. Well, what are we going to do? The lowest data is 78. The maximum data entry is 159. We can use the STEM values for 7 to 15. To construct the plot, list these stems to the left of vertical line. For example, for data entry 155, the stem is 15 and the leaf is 5. What do we mean by that? So here you have 155. This is your stem, which is 15, and 5 is the leaf on the right-hand side. Let's begin. So the minimum data entry is 78. 7 is the stem, and 8 is the leaf. We don't have any 80, 81, 82, 83, and so on. We're still going to write down 8 as the stem, and we're going to leave nothing on the leaf area. We don't have any 90, 91, 92. So we're going to list the stem 9, and there is no leaf. The next number is 105. So 10 on the left-hand side and 5 on the right-hand side. We also have 108. So 10 on the left-hand side, 8 on the right-hand side. We can basically just take a look at this data. Remember, we use 78 and 105. Let me find it, which is just right here. Then you have 108 here. Then you have 109, 1, 2. So we expect so far to have 2 9s on the right-hand side. And take a look. I have another 109. So if you just cross this off, you see you have 3 9s. The next number is 112. And 112 is repeated 3 times. You can just take a look at the data set. 1, 2. And let me find the next one. Down here. Then you have 113. So that's why you see 11. Then you have a 3. Then 114, 116, 117, and so on. So you continue the process. Then you go to the next set, 121, which is repeated twice. Let me show you. 121 is just here and also here. So that's why you have 12 and 2 1s because of the repetition and the rest of the numbers. Then you have 130, 132, 133, and so on. Then you have 140, 142, and then you have 155, 159. And that's how you visualize the data using stem and leaf plot. Other than stem and leaf, you can use dot plots. A dot plot is a way to represent the data and it easily help you to identify any outlier. Each observation is represented by a dot. And if you have repeated observation, you're going to put dot on top of each other. For example, The figure below shows a dot plot for orange temperature data. So this is our figure, and as you can see, you have dot on top of different numbers. And as you can see here, well, the majority of the data are located on the right-hand side. So it seems like the graph has a tail on the left and we call it left-tailed graph. Another example for you. A major food processor regularly monitors bacteria along production lines that include the stuffing process for meat products. An engineer records the maximum amount of bacteria present along the production line. So you have these information. You have the data set, and you're interested in visualizing the data. Take a look. If you use a dot plot, you have one dot which is far away from the rest of the data. This dot represents an outlier. The majority of the data are located on the left-hand side. So the distribution is on the left-hand side, and you have one dot which is far away from the rest of the data on the right-hand side. Remember that when you have unusual value, we call it outlier. When it comes to data science, we can ignore outlier or we can take outlier into account, depends on the data.